Hello again. This is the Laboratory of Science, Innovation and Business. We provide you different instrumentation for different measurements to improve your research and business. Today we shortly talk about thermal or thermographic cameras, how it works, what is it for and how to use it. So how it works? The thermal camera in general is like RGB camera, but in similar way to night vision devices, it sees beyond the visible spectrum in infrared range. So using such a camera you can see at night. For example, here we see buildings, houses. Houses are warmer than the environment and emit more infrared radiation, so they are brighter. This is the background of thermal imaging. As you probably know, according to the Planck's law, all bodies around us emit radiation. The emission spectrum depends on the temperature of the object. Here you can see the spectrum of the sun, which is as hot as 5000 degrees. And most of radiation of the sun is in visible range, as you see. This curve is temperature of incandescent lamp at 2000 degrees, and we know we can see it. Here is a hot iron. It is a hot body, which is reddish, and we can see it also. However, most of radiation here comes to the infrared range. And here we see emission spectrum at room temperature. At room temperatures, almost all emission of the bodies come to the infrared range, and in visible range such a body cannot be seen. However, the amount of infrared emission depends on the body temperature, and the thermographic camera sees hotter objects as brighter. This is the principle of operation of thermal camera. It's sensitive to far infrared radiation. So let's take such a camera, couple with conventional RGB camera, and record two videos simultaneously, the first in visible and the second in infrared light, and let's see what we can see. Okay, here you can see a fireplace with a long chimney, several meters. Probably 4 meters. The fire is on, however, how hot the chimney is we don't see here. So let's start the thermal camera. Okay, now we see different colors. More white and red means hotter object. Blue and dark blue is colder. So the fireplace is 270 degrees. This is not high because the door made of glass, which protects the fireplace and blocks some infrared radiation. Well, but the chimney is also hot, 100 degrees. And if we go up, the temperature goes down to 70. So this long chimney looks efficient part of the heating system. Now we are on the street, but the main things are cars. We can see when the car arrived to the parking place. First two cars came a long time ago and they are cold. And the third one is much warmer, as it probably has arrived some minutes ago. And this passing car is very hot and the motor is on right now. Now we see people. This is the principle of night vision devices. Humans are brighter as they are warmer than environment. And again you see buildings. Buildings are red. Using such a camera it's easy to find problems with the heat losses in buildings. If you find those problems, then you can try to fix them later. And here is some quantitative, more scientific application of the camera. We record a video of a small water pool on the surface. We warm the water with our finger for a while, then we remove the finger and we record how the water cools down. To do it quantitatively, we open the recorded video in some software and analyze it frame by frame. In this particular case we use MATLAB. We track the temperature in small red rectangular area. Here is a chart of the temperature going down in this area. So this can be done anywhere in the lab conditions or in the office or outdoors. You can image big and relatively small objects. We can help you to arrange such measurements with a thermal camera and develop a code for software analysis. In addition to thermal cameras, we have many other useful devices: cameras, spectrophotometers, microscopes. Search for what is interesting for you on our channel and do not hesitate to contact us to ask help.